Hi. All right, we're now going to discuss how to deploy the Cisco SD-WAN controllers on-prem. Basically, you have a choice of deploying them in your own public or private cloud or at your data center. As well as we're also going to cover how to set up an enterprise certificate authority if you're a managed service or provider. Okay, and we're actually sitting down on, we're going to go through actually the next section. So, okay. And we're going to deploy, basically we're going to run through the OVFs and how to deploy each controller in VMware. Okay? So, when you install controllers on sites, the requirements are as follows. Remember, our SD-WAN architecture enforces a strict separation of the management and control planes. For this reason, all controllers must have two interfaces. So when they deploy these OVFs, we're going to have two VNICs in them. One for VPN 0 for the control interface and one for VPN 512 for the management interface. On the control interface, only control protocols are permitted. VPN 0 is always the control interface. If you hear VPN 0, I want you to translate that in your head to control. Okay? If you hear VPN 512, I want you to translate that to mean management. And as like the control interface, on the management interface, only management protocols, SSH and HTTPS, are going to be permitted. And this basically enforces a strict zone-based security model. At first installation, only a few parameters are required for bringing up a management plane between the controllers. Connectivity, system IP, site ID, organization name, and the vBond IP. And by connectivity, I mean like IP address, subnet mask, and default gateway. You can deploy the controllers on any hypervisor shown on this slide, ESXi, KVM, AWS, or MS Azure. Okay, so step one, go to Cisco.com and go to the we'll have the virtualization description in the next slides. Basically what we're going to do is we're going to download an OVF. We're going to perform the installation and initial configuration, host name, NTP. We'll then configure the system IP, site ID, and organization name. And if we have a local CA, we're going to install that root CA chain and resynchronize those vManage databases. Okay? So for vManage, remember this is our single pane of glass. This is where we're going to configure the entire system. This is where we're going to be monitoring the system. So we're going to have two drives on this one, but I want to mention that we're going to have an install drive and then we're going to have a database volume as well. So note that here in this column that we're going to have a database volume. Please also note this at the bottom that only solid-state drives are currently supported. And it's going to be sized based on the number of sites that are supported. So remember, if we have multiple vEdges in a site, that still counts as one site. Okay? So to install the OVF template, select it in Deploy OVF template in VMware. Select the OVF, and then make sure you thick provision it. The reason we want to thick provision these is we don't want to have delays while we're expanding the volume. Okay? We're going to do thick provision lazy zeroed. So just so you're aware, in the OVF, there's only one network controller. We're going to add another one afterwards. But make sure you choose the controller's LAN for connecting to this, because we're going to connect to it via the controller's LAN to do all the configuration. Okay? After the configuration settings, click Finish. Don't power it on yet. We're going to add a couple of things. We have to add a hard disk for the database volume and a network interface card for our management connection. And we also require a second hard disk, which is sort of the large database. Let's go back here. I just want to take this back real quick so you can see the size of that drive you're going to have to add for each of the sizes. So if you've got 1,000 sites, we're going to want to add a second 1 terabyte volume for that database. Okay? And basically, you just go to Add on the hardware. So basically, edit settings on the system, and then go add a hard disk. We're going to add a hard disk, and then we're also going to add an Ethernet adapter. We'll create a new disk. Also, thick provision lazy zero. It's going to be 100 gig in this example. This is going to contain all that configuration and operational data for the entire network, or networks if it's multi-tenant. Thus, a significant amount of disk space is going to be required for this database. And make sure that the virtual device node is IDE 0:1. SCSI will not work in this. Okay. And then we're going to need an Ethernet adapter. And then making sure, and then label it, and then put it in the management LAN. The first one, remember, was the controller's LAN. So remember, this is VPN 512. The other one was VPN 0. Just so you know, this is the wiring up of the VM and must be done correctly to have connectivity. Remember, we need to maintain sure both of this connectivity is available. Otherwise, we won't be able to bring up the environment. Okay? At the first boot, you're going to have to choose which of the 2 available storage devices to use for the vManage database. You're probably going to want to choose the big one you just added, that you just set up. Before usage, of course, you're going to need to format it. Then vManage is going to reboot and are ready for initial configuration. Okay? So it's basically limited to 5 basic parameters. It really isn't a lot of configuration. Basically, the system IP. In here, it's a real IP address. Let me note this guy. So here's the real IP address that we set. That can be anything. It can be, as long as it looks like an IP address, so it's 255, 1 through 255 in each field, but it's not actually a routable ID. We have our site ID, our organization name. I'd like to note, this must match on every single node. If it's got a space or one of them is not capitalized or something, they will not connect together as the same organization. We're also going to specify the IP address of vBond here. This is really, really important. And then we're going to do a commit and quit. Now, the way we save this, so if you're familiar with Cisco routers, you do config T, you configure stuff, hit exit. Every time you type a command, it automatically takes effect. In this, we're going to do a commit and quit to actually get that to save. On the management side, so now remember we're VPN 512, we're going to specify an interface. Basically, this attaches that interface to this VPN. Okay, so interfaces are subject to subordinate to the VPNs they're assigned to. And here's an IP address. We always enter these as CIDR notation. If you're not familiar, that's classless interdomain routing, which means it's the IP address, a slash, and then the number of subnet bits. Okay, that's all you need to configure a vManage. I know I scribbled all over that, but there isn't much more configuration than that from a vManage standpoint. Okay. And then we have to create a transport interface. On the transport interface, again, it's VPN 0. All right, we put an interface inside VPN 0. Sorry, I crossed that out when I meant to underline it. Again, IP address, no shut it, of course. Exit, and then we're going to add a route statement. Okay. Again, we're classless interdomain routing again, so it's a 0-0 route, and the next hop is 10.0.0.1. This needs to be routable, of course, and this is how we're going to actually have our connection. You can kind of think of VPNs like VRFs, virtual routing and forwarders, and you assign interfaces to VPNs, and then you configure. Each VPN is going to have its own default route. In the example in this configure, you can see the default route for that transport. And of course, we also need NTP, because if we don't have NTP, we can't synchronize logs, and if we can't synchronize logs at the same time, we can't correlate log entries, so which means we can't do any analysis. So NTP forever. All right, so let's say you're not using the built-in certificates and you're using a local certificate authority, let's say Microsoft Certificate Authority or any other. We're going to need to copy that root certificate into the system. Okay. So remember, all the SD-WAN devices are going to use certificates to authenticate all communications. All right. Each device has to have the trust anchor, which is the root certificate of the certificate authority. And we're going to use this root CA to authenticate all the other devices' certificate, which is also going to be signed by the same CA. Okay. So after that CA root certificate is on the system, then we're going to import it using the CLI shown in the figure. This is an API call. So if you've never seen one of these before, basically what we're doing is we opened a URL to this guy. This executes that API, and then we get a done back indicating that it was successful. Okay. And of course, it's the vManage IP, whatever the IP address of the vManage you just set up. Okay. And we mentioned APIs before. I wanted to mention that we do actually use an API here. And then we have 2 commands we can do to make sure that the certificate took. Basically, we're going to do that show certificate root CA. And what we want to make sure is on all devices, the root CA matches serial number and matches the issuer. And then I'd also like to note something here. The validity range. If it's expired, if the certificate's expired, we're not going to be able to do it. Okay. We're not going to be able to use that certificate if it's expired. In which case, that one's expired. Woo! Wait, that was a month-long certificate? That is not a lengthy certificate. Generally, you're going to want your certificates to last at least 3 years or so, because updating all of the certificates on all the devices can be time-consuming. So obviously, we're not going to want to issue them in month-long increments. So then we're going to go into the vManage. We're actually going to log into the vManage itself. And then we're going to go to Administrator System. And then we're going to configure the vBond IP address in the GUI as well. And remember, I don't want to go all the way back, but we did on the CLI, we also configured it here. We configured it there and we gave it the IP address of the vBond. We're also doing it here. I'd like you to note the port number that we're connecting to. Okay? Those are the control, that's one of the examples of the control ports. We're going to go into them. There's actually a range of them, so if it doesn't work on the first one, we then try the second, third, and fourth. If you don't do this, the bootstrap configuration for vEdge Cloud won't work. Generally, don't change this port number. This is the default here. Misconfigure a port number, it's going to just not connect. And if several vBond orchestrators are required, so let's say you have 5 or 6, most of the time we only have one because it's only used for initial bootstrap. We don't use it every time we come up. It's that initial time so we can find our other servers. So you don't need hundreds of them. But if you do feel the need that you do want to, we're going to specify a DNS name here, and then we'll have to do DNS load balancing configured separately off box. We'll have a scaling section. And that's the end of vManage. We're done with vManage. Yay. Now, okay, let's talk about vBond. It's remarkably similar. Okay, we're going to deploy the OVF software. Okay, perform the initial configuration. And configure all that system ID information that we configure just the same way as vManage. Remember, if you don't recall, vBond is that first point of contact of every device in the SD-WAN environment. Controllers, edge devices, everyone needs to talk to vBond when they first come up so they can find the rest of the servers. So after every reboot and that first installation, each device in the fabric first reaches out to vBond to discover all those other controllers, detect whether they're behind NAT. And this is why the vBond IP address must be hard configured on all devices. We'll talk about zero-touch deployment later, but that's the only case in which we don't actually configure vBond locally. Setup of vBond is basically the same as vManage. We'll talk about the nodal accession as we get there. By the way, vBond and vEdge use the same software. So when deploying an OVF template, you're going to use the vEdge OVF template. So if you go to Cisco's website and you're downloading software and you don't see one for vBond, use the one for the vEdge. Okay? And here are the VMware requirements. And again, only SSD volumes are supported. Okay? All right. The big difference between the configuration, and if you take a look, the configuration is basically the same. We have a host name. We have a system IP. We have a site ID. We have the same organization name. The key giant thing is that vBond, we're going to tell it the vBond is local. Local indicates that this is the vBond. Okay. Other than that, this is exactly with the local. That's it. It's the only way to tell that this device itself is the vBond. Otherwise, we would not say local, and we'd be telling it this is where vBond is to go connect to, and then commit and quit to save those configuration changes. Okay. And then we configure interfaces the same as any other device. VPN 512 management, VPN 0's transport. By the way, if I tell you that 43 more times, I get a coffee maker. Okay, and here's an example of the configuration of VPN 512. Remember, we're assigning interfaces to the VPN, and then we assign the IP address, no shut, commit and quit. By default, like most Cisco devices, all interfaces boot up in a shutdown state, so you will need to no shut the physical interfaces. Logical interfaces, of course, come up as in the up state, other than VLANs. Anyway, by the way, this is we've kind of Ciscoized the CLI, so question mark works fine. Autocomplete with tab works. A lot of the commands that you're used to working work fine. Okay. So remember we talked about the fact that we had pretty strong zone security between the control interface and the management interface, and on VPN 0, excuse me. We'd only allow VPN 0 tunnels, and on VPN 512 we only allow management protocols, right? Because of this strict separation, we need to make sure that we all the only control protocols are going to be committed on by default, like say on the control interface, only tunnel interfaces. So if we're terminating a tunnel, we can terminate it on VPN 0. We can't do that on VPN 512, which is a management interface and only terminates SSH and HTTPS sessions. Okay. During setup, this strict separation must be loosened a little bit. We're going to require some additional protocols for the setup phase over the control interface. Okay, and the reason is that we're going to be running netconf. So we're going to lower that transport interface. So on VPN 0, okay, remember we were mentioning VPN 0. We have an interface, IP address. We're actually going to disable the tunnel interface. This is what tells it that it's actually a VPN 0 secure interface. Okay. Basically, we'll turn off the tunnel interface. Now we allow netconf so that we can get configuration to the device. However, during operation, the tunnel interface is required, so we won't be able to form tunnels with this command on there, but we need it for configuration. So we're going to have to reconfigure this tunnel interface after the controller is set up. So under the tunnel interface configuration, you can allow those specific protocols. What I would do instead of this, this no tunnel interface, is we can actually allow protocol netconf, which would actually allow it to connect without taking down our tunnel capability. And then you would remove it afterwards. Okay? And again, now we have to copy the root CA over to the device. So all these devices are actually running Linux, and then they're running the vBond software or vEdge software on top of it. So what we can do to get into that Linux shell, all we have to type is vshell on the interface, right? And then we're in the back-end system. And basically what we do is we just do a request root search chain model, and then we specify the address we're getting it from. And then we transfer it in and perform the installation. So the vSmart installation process is largely the same as the ones for vBond and vManage. We're basically going to determine those system requirements, and then we'll upload the OVF template and perform the installation. And then we'll configure that basic initial configuration, hostname, NTP, system ID, etc. And here's the VMware requirements depending on the number of sites you have. And again, only SSD-based volumes are supported. In summary, that cloud deployment is going to be the recommended method. Let Cisco manage those sites for you. Don't spend the time deploying and managing the connectivity to those servers when you can have Cisco do that for you. However, if you need to, you can deploy those on-premise for yourself, but you need to make sure that IP reachability, firewalling, and NAT is taken care of. And MSPs can use this in multi-tenant mode. And remember, we do require a valid certificate on every single node so that we can negotiate those security tunnels. Remember, these can be public certs, or you can use a local certificate authority. And in NAT environments, you're going to be required to use the right color to make sure that the tunnel interfaces connect directly to each other. And thank you for watching.